Okay, so this is week 5 of the online physics class, our lab, and wanted to introduce you to our new topic. Let me go ahead and begin sharing my screen. So the screen that's going to pop up is it's a split screen, so you should see two screens here. The one on the right pertains to the directions for the lab, and let me back out a little bit so you can see how I got here. So under course content, you'll click under the week or the experiment 4, even though this is week 5. Remember, the addition and resolution of vectors was a 2-week lab. So experiment 4 is where we're going to be at. And so you'll see directions actually in 2 places. You'll see it right below the document. And when you open the document, right below the document, you'll see the same directions. Just did that for clarity. Wasn't sure of how else to put it. I could have embedded it in here, but I thought it would have been a little bit messy, and I have to clean this up. So you'll probably see a little bit different when you pick it up. So with this lab, what we're trying to do is we're trying to determine how far an object is going to go given certain initial conditions. So on the left here, you'll see our cannon, and kind of disregard some of this stuff down here. You got a little man and you got a target. This simulation kind of plays off of a game, so I wouldn't worry too much about that. So what you're going to do is you're going to go into this the intro lab here and kind of play around with some of the tools. Just understand that when you have this cannon on the ground, it will not tilt to less than 25 degrees, and it will not tilt beyond 90 degrees. Now, there's going to be a problem on here where you're going to have to look at it from the perspective of, what happens at 20 degrees. So at this point here, you're going to have to kind of look at your data to make some kind of speculation as to what would happen. So let's go through this real quick. It's a fairly easy simulation to operate. The tools here give you basically where your object is going to be once I get the path drawn out, and we have a tape measure as well. So as I go through this, let's start up here at the very beginning in the intro screen. What we're going to do is we're going to set our initial height at 0 meters. So you can see over here that we're on the ground, and we're going to select any of the objects. So you can select a pumpkin, a cannonball, a golf ball, whatever. So let's just select the pumpkin. Won't matter. And it won't matter for our purposes because we're going to basically set it so there's no air resistance. And we're going to uncheck air resistance. We don't want any air resistance. So if there was an object such as cannonball versus a man in the air who's kind of flailing in the air, that flailing or that volume that he creates is going to create some air resistance. So we can play around, or you can play around with that, but we're just trying to give you some baseline understanding of what happens given some initial conditions. All right, so you're going to complete data table 1 to get a better understanding. And getting again, I say note that you can't go less than 25 degrees. You're going to answer this question in here once you get through the exercise. So basically what you're going to do here is You really don't need to click too many of these vector components. You could see. So what you do is just hit that red button to fire away. You'll see it go up, trace out a path. And so what this tool does, it's really helpful, is on each one of these little dots here, it'll give you some information about the time, the range being the horizontal distance, and the height, which is the vertical distance. Okay. And you might want to also double check yourself. You know, this is a yard, a tape measure that kind of gives you an idea and understanding. So using this tape measure, I'm assuming that this is our 0 spot right here where the origin is. It looks like it's about 21.67 meters. And if I took this range finder up, it looks like it's roughly about the same, right? Plus or minus a little bit, because I'm not sure how accurate I was to being right on that origin. Okay. So play around with some of the tools here and answer each one of those questions in terms of the range. Then you're going to go to data table number 2. And again, you're going to set up these initial conditions and you're going to fill in this chart. So where you see the yellow, you should clear that out and fill in your information. So I need to know the time in this column here. So you're going to fill in the time. So right in here, you're going to want to select the time before it reaches the max height. So let's give you some initial conditions a little bit different than this. So I'm going to set the initial conditions at 30 meters per second. I'm going to clear this out. I'm going to set my angle of inclination to be, set it at 55 degrees, and my initial height is 0 meters. And so, again, I want no air resistance. I want no drag to occur with this. And I'll take some of this stuff away. Seeing the velocity components might be pretty interesting. And I'll move this tool back up here. So I think I may need a little bit of room, but let's just go ahead and shoot it off and see. Yeah, so I'm going to need a little bit more room than that. So what you can do is just kind of minimize the screen a little bit here, and you can kind of see what's going on. So given these initial conditions, it looks like this object is going to fly a horizontal distance or a range of 86.2 meters. Now, there's some key points up here that you're going to want to pay attention to. You're going to also want to pay attention to the max height. In this particular setup, the max height appears to be right here at that little green dot. So you have to kind of hover over it a little bit to get it to select. And it looks like that max height to be at about 30, roughly 31 meters. And again, if you want to kind of double check yourself to see, you can get this little meter stick or this tape measure. I'm not sure if it goes, I guess it can. Yep, you can turn it. You can see it's roughly about, the same distance, right? Okay, so just to be clear, you're gonna need to make sure you put the number that corresponds in here, and in this column where it says initial, insert a time before the max height. You can select any time in between the max height and the 0 point. So for example, in this particular instance, the height was the time when the height was maximized was 2.5 seconds. So I can choose anything between 0 and 2.5. So I can choose, say, this point at 1 second. It doesn't matter, right? And then same thing on the right side. I'm sorry, in this table, I say insert a time after the max height. So you're just going to select another time over here. You have to get this little radar thing to click on one of the dots, and you should be good. Now, the last point is in the first column here, corresponds to when it strikes the ground. And so you want to be careful here, because when it strikes the ground, you should get some value, but it's going to look like it's at about 0.25 meters. And that's about the best it's going to do. Theoretically, the height and the height should be 0. Oh, it gets you to that point. So theoretically, the height should be 0, and also the velocity is 0. So you're going to want to be careful when you go through the second part over here on the right side of this. So what I can do here, let's see. So when the height strikes the ground, that asterisk should be okay. So I need to change this. And it's basically what I'm saying is, it's okay to assume that you're analyzing a projectile split second before it strikes the ground. So what you don't want to do is you don't want to let the velocity go to 0 at that point. So I'll show you what to do. So let's go back up here, and you're going to see that on the right side here of this table, what you're going to need to do is you're going to need to fill in what the horizontal velocity components are. Right, and this has to be done using some hand calculations. So you're going to look in your book, you should be able to determine the horizontal component of the velocity vector. So let me show you what that looks like here real quick. I'm going to clear this out, and I'm going to slow this up a little bit here. So I'm going to show both components. I'm going to zoom in just a little bit so you can get a better view. Just going to go through a couple stages here. So I'm going to fire it off. All right, oops, do that. Let's clear this out. So let's fire it off, and let's pause right here. Okay, so on the left side, you can see that the vertical component of the velocity vector points up and has some magnitude. Now, you're not going to be able to determine that. And you should also see that the horizontal component of the velocity vector has some magnitude as well. If I put this total piece in here, this sums up these two velocity vectors. So you're going to need to analyze and figure out what's going on. You're going to need to figure out exactly what that horizontal velocity and the vertical velocity vector are. So one thing to kind of keep note of as I step you through this, pay attention to the length of the horizontal, this horizontal velocity vector. And so I'm slowly clicking through here. Okay. Right about here is where the max, where it's at its apex. In other words, the vertical velocity vector is 0. It's not going up anymore. Right. So again, still watch that horizontal velocity vector. And so you should note some things here that about what its magnitude is. So let's just make an example. Let's just say that its horizontal velocity vector is, I'm making up a number now, is 20 meters per second in this instant. So all throughout this path, this object is traveling to the right at 20 meters per second. So this is what we talk about for free fall motion or projectile motion. Okay. So as things go through the air, we should be able to predict what's going on. And so I'm going to have you answer some questions in here about what's going on in your second row of data, your fourth row, and your fifth row of data. So you need to do those calculations in here. Now for data table number 3, what you're going to do is, again, you're going to set the initial height, the initial velocity at 20 meters per second, the initial angle at 45, but this time you're going to raise the height of this to 5 meters. Right, so I have to zoom in a little bit. So you have to click this little X box here and raise it up to about 5 meters. All right, you want to clear this out and you want to tilt it to the appropriate angle. So I'm not going to do it, but you can. I'll just go ahead and set it to something really small. Probably not going to go very far. And you can see that, boom, it's going to drop down and actually hit the man. Okay. All right, and then same thing over here. You're going to give me some answers to your second and fourth and fifth row data. So you're going to show me how you got those calculations, the horizontal velocity vector, the vertical velocity vector, so on and so forth. So you're going to need to type those things out. So no handwritten information. Everything should be typed out. Okay, other than that, if you have any questions, feel free to email me or give me a call, and I wish you well. Take care.